SwayamPrabha. Digital India. Educated India.
Welcome to the next lecture on quality assurance. Last lecture we discussed about quality. Quality is very interesting terminology which is very hard for developing a definition. Finally, people say if you can confer to all the specifications whatever you have given, then we say it is a quality product. Quality is very difficult to have direct units to measure. We always use indirect ways of measuring and then we try to link it with the quality. Okay. So, that is what is quality, but without quality you can't live. So, that means to say quality is very difficult to measure, but it has to be measured, and without that people will not accept your product. So, quality is pretty interesting. Like for example, you can take a hotel industry, quality of the hospitality. Then you might take a pen, quality of its writing. You might take a TV, quality of the eye comfort it gives, quality of the sofa, the way it sits, quality of your pant, what you wear. Okay. And interestingly, if you buy a jeans pant and the jeans pant is worth of 2000 rupees, and there is one of the parts is the button which is there on your jeans pant, if that button maybe costs 1/5 of it or 1/10 of it or maybe even 1/100th of the cost of the entire jeans pant, but if the quality of that button is bad, then the entire pant sale dies off. So, quality at every part, at every product is very, very important. And the other interesting thing is nobody is going to pay extra money for the quality. For example, if somebody comes and says, here is a product which is 10 rupees and I have made a 100% quality check, give me 12 rupees, people will say hell with you. So, if you say 2 rupees more just for quality, people are not going to accept it. So, now it is very clear that quality has to be integral part of your manufacturing itself. When you do that, there has to be an assurance which has to be generated while you develop or while you produce in the process. So, that is what is quality assurance. So, in this lecture we will try to see an introduction, then process capability analysis using control charts, then we will try to see process capability analysis using DOE, then engineering process control, then we will see process monitoring and process regulation, process control by feedback adjustment and combining statistical process control with engineering process control. So, statistical techniques, see 100% inspection is not possible. So, then what we have to do is we always try to do a random checking. Okay. So, then statistical techniques come up in a big way to help in maintaining good quality products. Okay. Statistical techniques can be helpful throughout the product cycle, including development activity prior to manufacturing, in qualifying process variability, in analyzing its variability relative to product requirements or specification, in assisting development and manufacturing in eliminating or greatly reducing its variability. So, what are we trying to talk about in quality is, first of all, if there are process variables involved in producing a part and the output of the part is Y and input process parameters are x1, x2, x3. So, what we are trying to find out is which is the significant parameter, and each parameter will have a range of values. So, which value to take such that I produce a good quality output in my product. So, the variability in analyzing this variability relative to the product requirement and specification, variability. So, this is a range. So, in this range say 20 to 40. So, here if I take 35, what is the variation I can allow such that I can try to produce the required output. In assisting development and manufacturing in eliminating or greatly reducing its variability, these are some of the help which statistical techniques do. This general activity is called process capability analysis. What is process capability analysis? Process capability refers to the uniformity of the process. For example, when I try to take a process, in this process, since there are machines, lot of moving parts, there is always a variability in the process parameters. Okay. So, how uniform I can maintain it such that the quality of the product is consistent. The variability of critical to quality characteristics in the process is a measure of uniformity of the output. There are two ways to think of its variability: the natural or inherent variability in a critical to quality characteristics at a specified time, that is instantaneous variability. The other one is the variability in a critical to quality characteristics over time. So, this is something like your wear which is happening to your moving objects over time, right. So, one is natural or inherent variable in a critical to quality characteristics at a specified time is called as instantaneous variability. So, there are two types of variable, one variable instantaneous, one variable happening over a period of time. So, these two are directly linked with your process capability. So, use an interpretation of CP. CP is a term wherein which is found out by critical upper specified limit or use upper critical limit. So, people call it as USL or sometimes people call it UCL. So, USL is upper specification limit and LSM is lower specification limit. Okay. Sigma is the standard deviation for the process. By doing this, we try to figure out what is the process capability. Okay. You can also try to take CP cap, wherein which we talk about a terminology called as sigma cap. So, the difference between these two is this. So, what is upper critical level is your upper specification limit minus mu mean is nothing but CP, and CPL is nothing but mu minus lower specification limit by 3 sigma. Okay. So, USL and LSL are upper and lower specification. For example, what we are talking about is this is the mean, this is the USL and this is the LSL and this is mu. This is what we are trying to say. Okay. The process capability ratio of an off-center process. The process capability ratio CP does not take into account where the process mean is located relative to the specification. It only talks about CP, whether the process is capable or not. Where is it mean? It does not talk. CP simply measures the spread of the specification relative to 6 sigma spread in the process, that is CP. So, then there is a terminology which is important. So, that is called as CPK, which is to be found out. This situation may be more accurately reflected by defining a new process capability ratio, CPK, that takes process centering into account. So, this is called process CPK. CP is found out by this and CPK is tried to find out by minimum of CPU, CPL is nothing but CPK. the normality and the process capability ratio. An important assumption underlying our discussion of process capability and the ratio Cp and Cpk is that their usual interpretation is based on normal distribution of the process output. It follows a bell-shaped curve. If the underlying distribution is no normal or non-normal, then the statement about expected process fallout attributes to a particular value of Cp or Cpk may be in error. That means to say, if there is a skewing happening in your distribution, maybe because of input of parts or maybe because of the machine which has some error, then this Cp or Cpk index will not hold good. Keep that in mind. This is very, very important. One approach to deal with this situation, above situation, is to transform the data so that the new transformed metrics the data have a normal distribution appearance. So, what you do is you try to convert the skewed information into a normal distribution by some transformation. That is what we try to talk about here. So, the normal and other approach has been considered in dealing with non-normal data. There have been various attempts to extend the definition of the standard capability index to the case of non-normal distribution. So, it was given in 1996 by a new index called as CPC, defining as CPC is nothing but upper specification limit minus lower specification limit divided by 6 root pi by 2 E x minus t, where the process target value is t is half of this plus this. Histogram, probability plot and process capability ratio summarizes the performance of the process. So, this is very important. Histogram, probability plot and the process capability ratio summarizes the overall process whether the process is good or whether the product produced from this process are capable to meet the specification. They do not necessarily display the potential capability of the process because they do not address the issue of statistical control, and they also show systemic pattern in process output that if eliminated would reduce the variability in the quality of characteristics. The other important thing is control charts. Control charts are effectively used in this way. Control charts should be regarded as the primary technique of process capability analysis. Cp, Cpk, all those things. Both attributes and variables. Attributes means, say for example, good bulb, bad bulb, attribute. Variable means 21.3, 21.4 diameter. So, attribute and variable control charts can be used for process capability analysis. The R chart should be used wherever possible because the greater power and better information they provide relative to the attribute charts. However, both P chart and C chart are used for analyzing the process capability, which is nothing but Cp and Cpk. When you use design for experiment DOE, designed experiment is systemic approach to vary the input controllable variables. So, I have told you earlier also there are controllable variables and uncontrollable variables. So, when you try to follow DOE, we try to take only controllable variables in the process and analyze the effect of these process variables onto the output. Design of experiments are used in discovering which set of process variables is influenced on the output, what level of these variables should be held for optimum process parameters. So, variables are x1, x2, x3 and the output is y. So, which variable is important and what is the range in which you choose such that you produce the output. That is what we are trying to say here. One of the major use of design of experiments is the isolation and estimation the source of variability in the process. There are two statistical based approach for addressing this problem. The first of this is statistical process monitoring by control charts and SPC, statistical process control. The focus of SPC is on identifying assignable costs, unassignable costs, assignable costs, so that they can be removed, thereby leading to permanent process improvement or reducing the variability. So, what we try to do is, when we assignable costs which are called as controllable. So, there are controllable and uncontrollable causes. For example, a newborn baby is to be given medicine for curing. So, the newborn baby, if the temperature has to be, if it is put in the free atmosphere, the temperature keeps changing, right. So, what people do is they put the newborn baby in a incubator. What do you do in an incubator? You try to convert all the variables which is uncontrollable into a controllable variable or into a controllable space. And here in the incubator, we vary the temperature, we vary time, we vary fluid input, whatever it is. What have we done is we have converted uncontrollable to controllable, and then in this we are trying to talk about the assignable cost. The second approach is based on adjusting the process using information about its current level or deviation from the desired target. This approach is called as feedback adjustment, and in the other form it is called as engineering process control. So, basically what we are trying to do is adjust the process using information about its current level or deviation from your desired target. So, you target value is there, what is the deviation you are trying to see. Feedback adjustment regulates the process to account for sources of variability that cannot be removed by the SPC process. So, now we are trying to compare EPC and SPC. So, EPC takes the feedback and then controls, right, process to account for the sources of variability that cannot be taken in the SPC. SPC does not get a feedback adjustment. So, EPC and SPC, if you see, engineering process control is a process compensation. EPS is always a feedback based. Process compensation or regulation scheme are widely used as stochastic control or the feedback or feed forward control, depending on the nature of the adjustment. Okay. So, it is stochastic, so random in nature, EPC. But whereas in SPC, it is binomial distribution has to be followed, it is controllable, and you follow some charts. This approach is based on the process compensation and regulation in which some manipulatable process variables is adjusted with the objective of keeping the process output on target. SPC has a long history of success used in discrete part manufacturing. EPC is used for continuous process. Please understand the difference. This is very important. That is found in chemical industry and process industry, we follow EPC, whereas SPC is followed wherever there is a discrete part manufacturing. A simple adjustment scheme, which is otherwise called as integral control, wherein which we try to talk about the feedback adjustment. In this, we consider a simple situation involving a process in which feedback adjustment is appropriate and highly effective. For example, pharmaceutical industry, shampoo producing industry, food producing industry, continuous. Okay. The process output characteristic of interest at time period T is YT, and we wish to keep YT as close as possible to target T. The process has a manipulatable variable X, and the change in X will produce all its effects on Y within one period, that is called as Y T plus 1 minus the target value gives you G of X minus 1, G of Xi. G is a constant which is called as process gain. the gain is likely a regression coefficient, because you try to have x1, x2, x3 variable and then you have so many x1s, so many x2s. So, it is a regression coefficient in that it relates the magnitude of change in xt to the change in yt, xt with the change in yt. If no adjustment is made, the process drifts away from the target to this position. So, now this is called the disturbance. So, there is an adjustable chart. So, this adjustable chart is nothing but when EPC or feedback adjustment is implemented, there is often an automatic process control which happens, which is nothing but APC. In many processes, the feedback adjustment can be made manual. The operating personnel routinely observes the current output deviation from the target, computes the amount of adjustment to be applied and then brings xt in the following equation and then he tries to do it. So, here we have mathematically represented, but generally what happens, he tries to check the, for example, sugar. What they do is, as and when the sugarcane juice gets converted into sugar, so at every stage what they do is they try to take an output and then try to put it on a glass strips, try to check the viscosity, and viscosity, by looking at the viscosity they try to play with the time and temperature to get a good quality output. So, this is done by experience, but if you want to mathematically put it, here is it, it is mathematically expressed xt and then xt minus 1, t is the target and this is the equation finally you get. So, when we have to combine SPC and EPC, this is for discrete, this is for continuous. Okay. This is considerably confusing, this is statistical, this is stochastic. Okay. This is considerably confusing about the process adjustment versus process monitoring. Adjustment, monitoring. Process adjustment or regulation has an important role in reducing the variability, SPC. There are many processes where some type of feedback control scheme would be preferable to a control chart. Control chart is given for SPC. So, there in which you talk about variables and then you also talk about attributes. In process where feedback control is used, there may be substantial improvement if control chart are also used for statistical process monitoring. Okay. In process where feedback control is used, there may be substantial improvement in if control charts are also used for statistical process monitoring as opposed to control. The control actions are based on engineering schemes. So, SPC, what you are supposed to know is discrete, SPC process control charts, SPC binomial distribution, EPC continuous, EPC feedback monitoring. They have found out an equation and then they try to bring it back to the target. A combining of these two is really very good, which people are nowadays started working on. The control charts that have been applied either to control error, the difference between the controlled variable and the target, to the sequence of adjustment to the manipulation variable, combination of these two basic approaches are made possible today. Point that lies outside the control limits of these charts would identify period during which the control error are large or during which the large changes to the manipulating variables are made. So, whenever your point goes out of control, you try to bring the process, this is out of control, this is your upper control, upper specification limit, lower specification limit mu. So, if you see that this might go outside the upper control limit and we just look for what is that. So, these periods would like to be good opportunities for search of assignable causes. So, target to students. So, just a simple example let us do. So, let us try to do an activity daily. For example, getting up in the morning and going to bed. So, please note down your daily scheme for 10 days. Note down the time, whatever it is, 6:15, 7:20, 5:30, whatever it is, and here you can say 9 p.m. You can also say 11:30 p.m. You can say 2 a.m., whatever it is. So, what you do is you try to list down all your processes. Okay? And then what you do is you try to calculate the mean for your process. You try to calculate the standard deviation for your process, right. So, you will now try to understand the process of getting up in the morning and going to bed. Does it follow a process sequence, and how good is your CP, and your standard deviation also talks about how good is your waking up and going to bed. So, with this you can try to figure out in real time what is your process mean, what is your process deviation, what is your CP and what is your CPK, so that you will try to understand the entire process. You just work on it, then you will know how good is your system. By knowing this, you will try to understand what are the process variables. Now you have got the mean, you have got the standard deviation, you have got the CP for the system, you have got the CPK for your system. Now you try to do a correction in your daily work and then re-record for the next 10 days after you have taken some necessary modifications in your regular routine. For example, every day before going to bed, I used to watch a serial. So, because of the serial, I sleep at varying time. So, I stopped watching serial. So, every day I go to bed at 9 o'clock. So, what have you done? You have first understood the process, then you have understood the standard deviation for the process, CP, CPK, and then you have now written out why is your sigma very high. So, you have listed down all the causes for your sigma very high. And now what you have done is you have tried to correct your process, and now you have once again recorded your mu and sigma, CP, CPK, and see whether there is any process improvement. So, what have you done? You have found out the cause, and then you have rectified the process such that it can be controllable. Thank you very much.